Welcome to this webinar for DS Lab 8.0. Uh, I would just like to uh, inform that we had done a similar webinar in the month of November last year. That was for DS Lab 7.6 version. So now we have come up with version 8.0. So I'll just take you through this PPT first. So this is the high level roadmap from 7.6 that we wanted to achieve in 8.0. So we had envisioned to undertake model migration, notebook migration. We wanted to improve substantially the performance of AutoML experiments, and we also wanted to make sure that we are able to do inferencing in pipeline using those AutoML models. Then model explainability is a new feature that we have come up with in a release 8.0. Then we have also made the feature import model functionality available to the user. We have also implemented the Pyspark environment along with TensorFlow and PyTorch, which were already there in 7.6. And then we also have enabled the usage of data preparation or the data sets which undergo some pre-processing using data prep module. We have enabled the usage of such data sets in AutoML experimentation. We have also enabled the ability to upload sandbox files from within DS Notebook. Now, people who have worked with Collab, they would realize that how easy it is to actually upload files from the notebook, Collab notebook session. So we have enabled a very similar thing in 8.0. Then we have also come up with resource utilization graphs. Again, people who use Google Colab, they would realize that while an experiment is under process, then we get a status for the CPU usage and RAM usage. So similar resource utilization status is available in DS Lab also. We have also enabled the preview notebook feature for which one does not need to actually activate the project. So this is also something which is very cool. And if you want to imagine, it's just like you open a notebook in Google Colab again, and you need not start the session, and you can just go through the entire notebook. So initially we had initially in DS Lab we had to activate a project, and only then we could see the contents of the notebook. But right now with the preview notebook feature, we need not actually activate the project. We can see the contents of the notebook without activating the project. Then we have implemented some UI uh, enhancements, like implementing drawer inside of DS Lab instead of pop-ups to give it a more user-friendly look. And then we have also come up with the generate copy path option for sandbox files in DS Lab. So if people again who use Collab, they would realize that at times it is actually important for data science professionals to make use of the path where they are saving the files and how to retrieve the files from those paths in case of computer vision or such projects. So we have implemented the copy path option for the same. So as you can see, this is one of the GIFs that we have attached for the AutoML experimentation. So I would actually take you through it fully, and I'll show you uh, an experiment that belongs to the classification group and an experiment that belongs to the regression group. And I'll just take you through the explainer dashboard as well. So this is similarly a regression explainer dashboard, and this is actually the AutoML screen. So I'll take you through it in the demo. Now we have also implemented the import external model feature. So what we are doing here is we can import uh, models that have been trained outside of our ecosystem. Those models can be imported into our ecosystem, and then those models can be used in our notebooks, and they can be used in our pipelines for inferencing as well. So I'll show one such example in the demo as well for import external models. Then we have also implemented the model migration feature. Now, using model migration feature, you can see we can export a particular model to GitLab, and we can give a particular name and click on yes. So this is the DS Lab notebook from where we are trying to export a model to GitLab. Now, this is user number one who is actually exporting the model to GitLab, and this has to be migrated to the user space of user number two. So now this is user number two who is going to use this model in his workspace. Now we can go to the configuration management, and we can go to version control. We can check migration, DS Labs, and from here we can actually choose the uh, model that we have actually migrated from user number one, and that model can then be utilized in the user space of user number two. So here you can see we are trying to import the model, and the name of the model was migration model underscore v1, which is the first in the list, and that model is going to be imported now into the space for user number two. So please bear in mind that user number one was the one who migrated the model, and user number two is going to use it. So we need to keep in mind that once we migrate a model, all the dependency files related to the model vis-a-vis the project and artifacts, they are shared. So you can see the name of the project that we migrated from user number one was project migration. The same project is now available in the space as project migration for user number two, and you can see the model is now available in the space of user number two. So this is something that we have achieved, and this also helps us in trying to share the work that we have done with our coworkers. On a similar note, we also have the ability now to share the notebooks with other users or to other spaces or to migrate them to other spaces. So again, the procedure is very similar to what I had just shown you in the previous slide. So we are able to migrate the notebook, and these can be migrated across spaces and servers, and they can include sklearn, Keras, and PyTorch related code. And it can also contain data sets, data preparations, utility files. All of these different artifacts associated with a notebook will be migrated, and all the dependency files, including the project that contains the notebook in user space for the user number one, will be migrated to the space for user number two. So this is also a very important feature. So you can see that the same project migration has been now migrated to the space for user number two, and the same notebook will be available. Export sklearn input. This is available now for user two as well. So this is something which is very important, and this helps in effective collaboration, and we are able to achieve this now as well in release 8.0. We have also implemented the feature for migrated model inferencing. So whatever in the slide where we showed you how to migrate the model from the user space 1 to user space 2. So that model can also be inferenced in a notebook. It can be used for prediction, and this is an example of that. So I loaded the model which I had migrated from user space 1 to the space of user number 2. And here I'm trying to do a prediction using the same model. And you can see that the predictions are served. So this is also something which is available now in release 8.0. And then we have made some UI enhancements for a variable explorer. So the variable explorer tool can now show the name, type, length, and the sample values for the variables, all the variables that we have actually created in the notebook. So you can see there is a tooltip that shows us the name, type, and shape of each and every variable. Then if you click on the pop-up icon, then the pop-up comes up and it shows you a detailed view of all the variables that are defined in the particular notebook. So this is also something which is very helpful for data scientists to use while they are working on a particular experiment. And then, as I mentioned, we have included the upload sandbox file from uh, DS Lab notebook. And you can see I just uh, went to datasets and I clicked on the plus option and then I chose sandbox. So all of these things I'm doing from inside the DS Lab notebook. And then I choose some file from my PC and I try to upload it here. All this while I have not come out of my DS Lab notebook. I'm still on the page where my DS Lab notebook is. And once I have uploaded my CSV file, I would be able to use it immediately inside my DS Lab notebook. So this is something which is very handy. Sometimes what happens is a user might forget to upload files to Sandbox, and he would have already started coding a notebook, and suddenly he realizes that I need to upload a particular file. For that, he need not go to the data center uh, tab and upload the file to Sandbox from that tab. So instead, what he can do is he can just upload the file from the DS Lab notebook using the Upload Sandbox file option. This is something that I had mentioned earlier, that we have also brought in the resource utilization uh, status for CPU and RAM usage. So this also shows a different color based upon the percentage of CPU and percentage of RAM utilized. This gives an indication to the user that what are the uh, areas of code that actually are very resource intensive and that result in a huge amount of CPU usage or huge amount of RAM usage, which can actually then prompt the user to do some code optimization to make sure that the resources are used more optimally. Uh, then again, we have also included the usage of drawers in DS Lab. You can see now while adding data sets or doing any operation, instead of a pop-up, we are getting drawers. So this is also something which is a very pleasing feature and gives a good user experience. So this is something that we have implemented in release 8.0, and this is available for all the different artifacts that are there in DS Lab notebook. And as I mentioned, I have we have also included the preview notebook option. So this is a project name is Feb3, and this is not activated. And I'm still able to preview a notebook titled Demo PyTorch ML Model. So you can see I'm still able to see the contents of the notebook. I can see what is the code inside it, and all this while the project is not activated. So this is a very good thing. I need not bring the container up if I don't want to. Maybe I just want to go and see the notebook and try and find what I had done previously. and then come out. I need not fire the container up and then deactivate it just to see the contents of the notebook if I don't have to execute any cell. And then finally, we have come up with this generate sandbox file copy path. So this is again an important feature. Sometimes while the data science team, they want to work on certain projects where it is required for them to know the path where they are storing their artifacts. So this can come in very handy. And from the ellipses on the right hand side, you have this copy path available and you can utilize it in your notebook. So now I'll quickly go to the. So this is the home page of our BDB decision platform. And from here, I would just go to DS Lab. Inside DS Lab, I have the first landing screen as that of the projects. And here are the different projects that I have created. And we are currently supporting 3 environments. So one of them is TensorFlow, another is PyTorch, and we have recently provided support for Pyspark. Pyspark support has been provided in release 8.0. So users can work in any of the 3 environments of their choice. So I'll quickly take you through model explainability. But before I take you to model explainability, I would just like to give you a brief information about how do we reach towards model explainability. So there are 2 ways of reaching model explainability. So one way is through AutoML, the models that we create out of AutoML experimentation. When we want to know more about those models, when we want to get more insight into the strength and weaknesses of those models created by AutoML, then we can go to model explainability. The other route is going through DS Lab, and the models that are created inside our DS Lab notebooks, those models are listed inside the models tab. So within this model tab, I will have all the models that are listed from AutoML as well as from DS Lab. So these models are all available for model explainability. So I'll show you that. So I'll just quickly go to the AutoML screen first. So this is the way number 1 via which I would want to go to model explainability. So I create an experimentation. Let me just quickly create an experiment. So the way I want to create an AutoML experiment is I would go to the AutoML tab and I would click create experiment. Once I click on create experiment, I would be taken to the dataset tab. So here are a whole bunch of datasets that I already have available for this particular project. The name of the project is demo. If I want any other dataset that needs to be added to this project, I can click on add dataset and I can include that dataset in this list. So I can quickly choose one dataset and probably run an AutoML experimentation for that. So it's just like I'll give the experiment name, I'll give a brief description about it. And I will choose the target column. I'll click on next. I'll just select the experiment type, whether it is a classification or a regression experiment. This one is a classification one because I want to classify the users, whether they survived the crash or they did not survive the crash of Titanic. So now the experiment has been created and the experiment is running now. So what happens once the experiment is completed? I would be getting a screen something like this. So this shows me the details. screen for the experiment that has completed recently. So the recommended model is mentioned here, the model name, the model score, the metric value, the date on which the experiment was created. Then we have the run summary, which tells us what was the experiment type. So the experiment type in this case using adult income classification dataset was classification. The model status is completed, and who is the one who has created the experiment, and what is the data set used, and what is the target column. Then we can go to models. These are the top 3 models that my AutoML has generated for the adult income dataset. And if I go to view explanation, I'll get some more information about the model. I'll get the model name. I'll get some performance metrics related to classification. So we get scores of precision recall and F1. So this is a very brief summary listed here. We can also see the information related to the data set that we have used. In this case, the adult data set. The adult data set has about 50,000 records, and we have used the column income as the target column. And it is a binary classification problem wherein the column has 2 possible values, greater than 50,000 and less than equal to 50,000. So this is the screen which tells us more about the data set that we have used, how many columns it has. And as I said, it has close to 50,000 records. How many missing cells are there, duplicate rows, total size in memory, and what are the different column types, numeric, categorical, etc. We also have the names of the columns, age, work class, and so on. We get information about them as well. And then we have these correlations. Then we also have missing value counts. We have a sample snapshot of the CSV file that we are using as an input. So this is the target column that we had used for our experimentation. And we also get the last rows. So this is a brief snapshot, quick overview of the data set that we have used for experimentation. Now we would like to go to Model Explainer. So as I said, this is the first way of going to Model Explainability dashboard, and this is through AutoML models. Now, as you can see, this explainability dashboard is actually dealing with the classification explainer. So we have the positive class and we have the negative class listed here. And we have different tabs. We have feature importance tab, we have classification stats tab, individual prediction, what if analysis, feature dependence. And all of these tabs give more information about the data that has been used in creating the predictions from a particular model. So this tells us that what are the different columns that actually contributed towards the positive prediction of the model that was generated by AutoML. So this is the model in question. Then we can also go to classification stats and we can see confusion matrix, and we can see precision plot. We can see classification plot. We have ROC AUC curve, precision AUC plot. We have lift curve, we have cumulative precision curve, and we have a whole bunch of filters on the screen which can be changed, and the values will change accordingly in all the charts. And we have individual predictions wherein we can check each and every record and see what is the probability of income being less than equal to 50,000 or greater than 50,000. So this is also something which is very intuitive for the user. Then we have a contributions plotting chart. We have a partial dependency plot chart. And this can also, we can include less number of features if we want. And this will change accordingly to the number of features that we are selecting. And if we want to select for a different record, then it will show us how the feature contribution has been towards the prediction for that particular record. And then this is the contribution table. Again, this is coming from the feature contributions chart. And we can also go to what if analysis. So in what if analysis, this is something which is a very important tool that can be utilized by business analysts, people who actually want to understand, for example, if this is a case of a person, having the probability of earning uh, less than $50,000 as 10% and a probability of earning less than more than 50,000 as 89%. So I think a better example would be to take something where the values are opposite. Because in any case, human beings want to increase their income rather than decrease. So this is a case where the probability of this person earning less than 50,000 uh, is about 94%, and his probability of earning more than 50,000 is 5.7%. So what steps can this person take, or what steps can the business analyst suggest to this individual such that his chances of earning more income increase? So what we can do is we can tweak these values here in the feature input. So it was 94% and 6%. So it has changed a bit. Okay, so let me tweak it a bit more. And those who know the data set, they will understand what is the relationship. It is like husband, family, own child, things of that sort. And the other logical thing would be to suggest that the person uh, undergoes higher education so that his chances of getting a decent job increases, and then his compensation would also increase. I can also include the age factor here. So if a person is like having the age of someone who has uh, completed his education and he is into job, so this will be more likely a scenario where he earns more than 50,000 in compensation. So as you can see, the value has changed. So as you can see, the chances of a person being at the age of 45, the chances of him earning an income in excess of $50,000 increases, because he would have already completed his education, and he would be having some experience also in the industry wherever he's working. So his chances of earning a higher income becomes more. So these are some suggestions that can be given to a particular user. So this is just an example, just to understand like that how uh, can these feature inputs be changed and tweaked, and an analysis can be made that how these feature inputs actually help in deciding the prediction. And this analysis will help the business team to take a decision of what needs to be conveyed to the users and how they can actually add value to the business and make sure that it helps the customers be loyal to the business and help the customers to remain with the business so that they reduce the amount of churn or things of that sort. So this is something which is very intuitive. And then we have contributions plot here as well. Then we have partial dependency plot also. And then we have a contributions table also. So since I have changed the values, so this will take a bit of time to get generated. And then we have feature dependence. It gives us a sharp summary table, and it also gives us a sharp dependency plot. and we can check a detailed and aggregate SHAP summary. So this is how we reach the explainability dashboard from AutoML models. And the other way of reaching here is through the models tab. So as you can see, I was checking the experiment adult underscore one, and I had just gone inside and I had clicked on model explainer and I was going through the explainer dashboard for the first model. But if I don't want to do that, I can go to the model tab, and there I can go and click on all models, and you can see the experiment name is listed here, adult underscore one. I can click on expand for models, and these are the three models that are generated from my AutoML experimentation. So I can click on model explainer, and it will take me to the same dashboard that we were viewing just a little while ago. So now I'll go back. So this is the first way of reaching model explainability dashboard through AutoML. The second way is through DS Lab notebooks. So it could be a scenario that I have created an experiment. Say, for example, I created an experiment in which I am trying to predict the possibility of a particular individual getting diabetes or not, based upon certain features which are there in the data. So I have created this experiment. I have used support vector classifier, and I have created a model. I have saved this model with the name of SVC model Pima underscore one. And once I save this model gets listed in the models tab. So as you can see, this model is listed here. And then using this model, I can do predictions. So as you can see, I just loaded the model and I did a prediction on the test set, and I got the predicted values. So this model that I have created out of the experimentation that I was doing in DS Lab, wherein I was writing a code. So in AutoML, you would have seen that I did not write any code. I just used the CSV file, I uploaded it to AutoML, and that's it. I sat back and I relaxed and I got the results. I got a model as an output. Now the same situation is being handled in a different manner. I am writing code. So I am writing code in order to understand uh, how to complete this use case and what is the model that I would be getting out of this experimentation. So this is the model that I get. Now I want to use this model in my explainability dashboard. So I'll go to model tab and I'll check for SVC model Pima underscore one. So this is the model SVC model Pima underscore one, which was created from DS Lab. So I'll just click on this icon here, model explainer, and it will take me to the model explainability dashboard. So here again, you can see there are two possible classes, 0 and 1, 0 being non-diabetic, 1 being diabetic. So these are the feature importances and the classification stats. Again, it's exactly the same thing what we had seen in the previous example, the model that we used from AutoML. And we again have the individual predictions and all the charts, and then we have same the what if analysis, and if we want we can tweak some values here and see how the predictions are affected. So if I give a value 100, so the predictions are affected here. So give a value of 120, so you can see that the predictions are changing. So this is how a business analyst can take some decision on, what are the different features that can be tweaked, and what are the different recommendations that can be given to a user in order to retain that customer or make sure that the customer does not leave the business. So this was the second route of reaching explainability dashboards. And now I would just like to show you how can we use these models in pipeline. So if you see, I had created this model. These are the top three models that came out of my AutoML experimentation titled adult_1. So I can register a model in order to push this model to pipeline, in order to deploy it into production and make sure that I run this model on a test data to do inference, I will have to register this model. So registering the model is very simple. You can see this icon. It says register. If you just click on it, it will ask you whether you want to register this model. You click on yes, and the model will get registered into the pipeline. Now, these models that I have shown you here, they belong to this experiment adult_1. So these models came out of AutoML. So out of these three models, two of them are registered. You can see the icon. So this indicates, so this icon is disabled, which indicates that these models are registered. Otherwise, you can click on the filter registered and you'll get a list of all the models that have been pushed to production. So you can see in the adult experiment, there are two models that are pushed to production. So what I can do now is I can use this model into my pipeline. So I have created a small pipeline where I'm reading some data in production, and I'm passing that data through my AutoML model. So my AutoML model is supposed to give me some predictions. Does it do that? So as we can see, I have created this DS Lab script runner. So in this DS Lab script runner, I have created a small script. So this script is nothing but it's trying to read the data. So I can show you this. I have created this small script over here. This is in DS Lab notebook. So I have just tried to read the adult data set, and I have created this small script here. So what I can do is I am reading the adult data set. So this is the adult data set. If I click on it, I'll get this code pre-populated. And then what I can do is I can export this piece of code. I can click on export. I'll export this piece of code to pipeline. And once this piece of code is exported to pipeline, I can use it in pipeline. Okay, I'll have to activate the project in order to do so. So let me activate the project. Okay, now that the project is activated, I can go inside. So this was the code, a small script that I had written to read the adult data set. I can click on export, and you can see that this is the script, and I can click on next. I can click on export, and this script will get exported to my pipeline. So this is the script that is appearing here. This is the script that is appearing over here. Using this script, I'll read the data, and once I have read the data, I'll just route it to a Kafka event, and then I have the AutoML model runner. Now the AutoML model runner is the one that will be utilizing the model that I have created out of AutoML experimentation.
So this is the model which I had created from adult_1 experiment, and the model name was random forest genie bag L1T1. So you can see this here. This is the model which I have pushed to production pipeline. So random forest genie bag. This is the random forest genie bag. So this is the model that I have pushed, and I had run this experiment already, and I had got the output, which is the prediction of whether an individual earns 50 more than 50,000 or less than 50,000 K. So you can see these are the predictions that I got. This is the prediction column. So based upon the data that I had given, I'm getting the predictions greater than 50,000 or less than equal to 50,000. So this is how a pipeline can be created, in no time, and you can start ingesting data. So I just gave you an example. You can even read data from any database, and you can pass the data to your model, and the model will serve predictions. So this is an example of a model coming out of AutoML being used in pipeline. The other example is of a model coming out of DS Lab and how it can be used in pipeline. The procedure is similar. So you have this model which I had created in my DS Lab notebook. So this was the notebook that I had used to create that model. So you can see this is the model that I had created, SPC model Pima_1. So this is the model that I had created, and I had registered this model from here. So as you can see, the models that are listed on the right hand side, which are created even from DS Lab notebook, they also can be registered. So currently I do not have any unregistered model, but if I want to register any model that I have created out in my DS Lab notebook, I just have to click on this ellipse button, and I can just click on register. So this icon will be registered. I can click on it, and then that model will be registered to pipeline. So, and it will get listed in the list of registered models. So this model is registered now. So I can go back. I can go back to the model tab, and you can see I have this model here. This model is already registered to pipeline. So I will now go to pipeline, and I will again read the data. I'm using a script once again. I'm using a script to read the data, and that script is coming from my DS Lab notebook. So this is the script that I'm utilizing. I'm doing nothing, but I'm using the Pima Indians dataset. Pima Indians diabetes dataset. I'm just using a small script to read that CSV file. And the procedure is absolutely the same as I had shown you before for reading that data from adult CSV file. And I just export this back to the pipeline. I export this script back to the pipeline. So this is the small script that I had written. And then once so I read this, I just click on Pima and I get this, and I make this into a function, because in order to export this script to pipeline, it has to be in the form of a function. And then the procedure is absolutely the same. I'll go here, I'll click on export. I'll export this script to pipeline. Once the script is exported to pipeline, it will get listed here. It will get listed here in my pipeline within meta information. So you can see the project name is demo, and the starting function is the name of the function, and the script name, read Pima script. So read Pima script is nothing but this one. This is read Pima script notebook. So that is getting listed here, and my script is getting listed here. So what I can do is then the same, I have the Kafka event, and then I have the DS Lab model runner now. So if you recall, in the previous pipeline, I had AutoML model runner. And in this pipeline, since I created the model inside my DS Lab notebook, I have the DS Lab model runner. So my DS Lab model runner will have the details of the model that I'm using. And you can see this is the name of the model, SVC model Pima underscore one. And then I can check the out event. So I had already executed these pipelines and I had read the production data and I passed it to the through the model that I created in side of DS Lab, and I got the output predictions whether the individual has diabetes or not. So you can see these are the predictions that I got. So this is the predictions column. So this is how easily, how quickly we can use our models. We can deploy them to production in pipeline. We can start ingesting data from any source, any database, and we can pass them through our models, whether they are created from AutoML or they are created from our inside DS Lab notebook. There's one another feature that I'd like to show you quickly, and that is related to import model functionality. So it could be possible that we have created some model outside of the BDB platform. It could be a Jupyter notebook, or it could be a Kaggle notebook, or it could be Google Colab. And we want to import that model into our ecosystem and then push it to pipeline to do inferencing. So we can do that by clicking on import model functionality. So once we click on import model functionality, we can actually choose the model that we want, which we have trained outside. And one such model is this, which I had trained outside. So you can see it appears with an icon E, which tells you that it is an external model. So this model can also be registered to pipeline. And once it has been registered to pipeline, this icon will be disabled. And you can go to the pipeline and you can actually create the pipeline and you can run it, and you will get the inferencing out of this. Okay, so this is the pipeline that I had created for the imported model that I had imported from outside. So you can see I have the DS Lab runner, and this is actually a script that I'm using. So this script is coming from here. You can see import models sklearn inference. So I'll just open it. And in this script, actually, I'm trying to make use of the model that I had imported from Colab. I'm making use of that model. I'm using it on some test data, and I'm trying to run a predict function on top of my model. And this code, again, I would be exporting it to pipeline. So the this is actually the model that I'm using. So this is the external model here. This is the model. So if I click on this, for example, if I click on this, so you can see the model ID is exactly the same as the model ID listed here. So I'm making use of this model in my DS Lab notebook, and I'm serving predictions, and I've created a script out of this. So I've created a script here. So this is the function, and I would be again exporting this function to pipeline. I have already verified that this function works and it serves predictions. So my external model is serving predictions to me. And now I would be exporting this to pipeline, and the manner of exporting the script is exactly the same as I had shown in the previous two cases by using the export option. So once this is exported to pipeline, I can use the DS Lab script runner, and I can use the script inside my meta information. So you can see that the script name is the notebook name, and this is the script that I have, which was in my DS Lab notebook. And this is the model ID, which I have imported from outside. So now I will just execute this and I'll get the outputs here. I'll get the predictions over here. And this is the same model which was run on the PIMA Indian diabetes dataset. So it gives a prediction whether a particular individual has diabetes or not. So the predictions would be 0 or 1. So these are the predictions that are served on production data. So this is something which is very easy. It can be utilized. So for this example, I just showed you a very simple script. You can actually ingest data and from any database, but for that you would have to create a script. So you'll have to create a script, and probably if you have data in your MongoDB, which is production data, so you ingest data from MongoDB, write a script for that, reading data from MongoDB, and then passing through your model, and then export that script into your pipeline. And once you have exported it into a pipeline, connect that to a Kafka event, and then just save your pipeline and execute it, and you'll get the predictions. So this is all that I wanted to say about import model functionality. Apart from that, there is one other functionality that I would just briefly like to touch upon. So this is the script that I was talking about. If you want to read the data from, say, a MongoDB, probably you can put your code here, MongoDB or any SQL database or whatever. You can read the data and then pass it on to your model. So you create a script and just export it to pipeline, and you can get the inference done. The other thing that I quickly wanted to touch upon was related to Pyspark. So I used a data set which is like a very huge data set. It has about 11 million records. And I tried to run outside of my in outside of the BDB platform, DS Lab environment. So I tried running it in Collab, and it actually took me about 2 minutes and 11 seconds to read that data set in Google Colab, and I was using about like very high configuration of CPU and RAM. The same data set I tried reading in Pyspark, in my Pyspark environment. I'll just show you that quickly. So the same data set I tried reading in my Pyspark environment, and it took me only 1 minute to read the entire data set. So it's like a 50% reduction in time taken to read the data set when I try to do that in Collab compared to when I try to read the same data set in DS Lab Pyspark environment. So this is the data set that I had used. This is the DTC Dubai Taxi Corporation dataset, and this dataset I had used in the Pyspark environment. So this is the Pyspark environment. Let me show you quickly that the environment that I have used for this project is actually Pyspark. So you can see this is the Pyspark environment for this project. So I'll just go back, and this is, so if I click on this, I get this cell pre-populated, and you can see I have just put a comment also that it takes 1 minute to read this data. So this is the advantage of using Pyspark in DS Lab. It helps us process large data sets with the capabilities of distributed processing, and it reduces the time taken to to complete the process. So this is something that we have provided in release 8.0. Right now, we have provided only read capability in Pyspark, and in the next release, we will be providing capability for writing also. So with that, I think I have come to the end of my presentation. If there are any questions, then probably we can take them now.
Okay, so my question is like earlier till 7.6, we have this export work option where we can export our scripts to pipeline. So now we have added option like we can do the Git export. So say I'm using some data set in my script. So if I'm exporting that particular or migrating that particular notebook to some other space.
Yes.
So okay, so will that particular data set will be migrated along with the notebook, or I need to separately share that data set or create that data set in that particular space?
It's a very good question, a very logical question. So, as I had mentioned earlier, whatever artifacts are associated with your notebook for that particular project, whether it is a data set, whether it is some file that you are creating out of your experimentation, it could be an image file, it could be a text file, it could be an Excel file. All of those artifacts are actually migrated into the new server and new space. So you need not create it newly.
Okay. And there is one other question.
Yeah.
So, say like we used whenever we create any model in DS Lab, like using Python code or some scripts. So we need to do some pre-processing of the data and
Yes.
for training the data.
Yes.
So, uh, do we need to pre-process the data to create an AutoML experiment? Like some pre-processing is required, or like basic cleaning is enough, or do we need some pre-processing just be doing like basic model creation?
Yes. That's again a very logical, excellent question. So to answer your question, I would say that at times the data that we supply to the AutoML, it might contain certain redundant columns like ID or record ID, which or sometimes it could be some columns which actually are empty totally. So those columns can be removed with a manual effort, just like you can go to the data processing center and you can just remove those two columns from there and then supply your CSV to AutoML. Else, if you supply it to AutoML, AutoML itself will do all the pre-processing that is required. But AutoML, what it does is it does not remove the columns. Logically, I as a human being, I will understand that ID column is not going to give any value addition to the predictions that I'm going to generate out of my model. So I will delete that column. I know it's a redundant column. It's of no use. But AutoML will treat that as another column. So the idea is a bit of pre-processing is a good thing. If you know your data well, you can probably remove one or two. Sometimes you have a column which at times when we share from one system to another from Jupyter Notebook, you download and put it into Collab and then download. There is a column, you generate an Excel sheet or a CSV. There is an extra column which comes and it is known as unnamed. So even that is a junk column. So that is also something if we see, we can immediately remove it by the pre-processing option that we have in DS Lab. We can remove that column and then the resulting file, the CSV file or Excel file, we can supply it to AutoML and it will then do all the pre-processing that is required and it will generate the predictions for the model and it will give the models as well.
Okay, that's it. Thanks for your answers.
Yeah, you're welcome. Any more questions?
Thank you, Amir, for the lovely session. It was very informative.
Yeah, thank you, Prakash. Let me take you there.